So hi everyone, welcome to Academitra. So basically today we are solving a physics question, a numerical question, which is from the chapter of friction, uh, which is basically the subset of the classical mechanics part of physics, right? So this is going to be a very short video, so let's not waste time. Let's just directly jump into this question, okay? So what it is saying, okay, sorry, I forgot to choose the pen, okay. Yes. So what it is saying? It is saying a block of mass 5 kg is placed on a horizontal surface. Okay. So we have the first information, which is mass of the block. We have the mass of the block, which is 5 kg. Okay, fine. Now it is saying it is placed on a horizontal surface. In case you don't know, I know that most of you know about what is the difference between vertical and horizontal. But in case you are a small child and you don't have idea about what is vertical and what is horizontal, so let me just demonstrate what is for vertical and what is horizontal. So this is basically the x-axis and this is y-axis. Okay, so in this diagram, this x-axis is basically horizontal and y-axis is basically the vertical one. Okay, so I think you understood already, right? You have basic idea about what is horizontal and what is vertical. So let's not drag this, okay, further. Now, okay, moving on to the next part. Okay, let me draw a free body diagram. Okay, so it is the hard and fast rule of solving a classical mechanics related problem. Okay, along with noting down the informations, you have to simultaneously draw the classical, sorry, the free body diagram. So this is, let's just assume this is the block of mass 5 kg and this is the vertical surface. Oh, sorry, extreme, sorry. I accidentally pressed the comma button. Sorry, extremely sorry. Okay. So we have the mass of the block, which is 5 kg. This is the block which is placed on a horizontal surface, and before solving this type of questions, you must have the prerequisites, which is the basic understanding about classical mechanics chapter friction. So you must have idea about what is friction. Okay, what is friction? Next, you must have idea about what is normal force. What is normal force? And you must have idea about what is coefficient of friction, right? Okay, so I'm assuming that if you are staying and you are solving along with me, then you have basic understanding about this chapter. Okay, even if you don't have any idea, I can assure you that in future, within a couple of weeks, I'll be teaching you and the basic theory about this chapter. Okay, so let's just jump into this numerical. Okay, so according to this free body diagram, this is the normal force. Okay, we denote normal force usually with the variable m. And what is normal force? Basically, in this normal force, as this surface is placed horizontally, so it is obvious that the force acting, what is normal force? The force acting perpendicular to the surface, right? So the force acting perpendicular to the surface will be basically what? Will be basically N equals to the weight of the block, right? And let's just assume a ball. This okay. This is a ball, and it is placed on a surface. Sorry. Okay, let's assume this is a ball, and it is placed on a surface. Now the weight of the ball will be perpendicular to the surface, right? So similarly, it will apply to the block also. The shape doesn't matter, right? So N will be the perpendicular force or the normal force acting perpendicular to the surface, horizontal surface, which is basically equals to mg. Weight equals to mg. M is the mass of the block and g is the acceleration due to gravity, right? The acceleration generated due to gravitational pull, which is equals to, we know that approximately 10 meter per second square, right? Ideally it is 9.81 or 9.8, but for solving numericals, we basically assume that it is nearly or approximately 10 meter per second square, right? So okay, let's move to the next part. So we have N equals to mg equals to what is it, 5 kg mass times g equals to what it is 10 meter per second square equals to 50 kg meter per second square, and kg meter per second square translates to Newton, right? So equals to 550 Newton. So N equals to 50 Newton. We already have it, right? Now let's just move to the next part, which is the mu. What is mu? Mu is basically the coefficient of friction. I already told you, right? So the coefficient of friction equals to mu is basically equals to 0.4. The coefficient of friction doesn't apply to only one surface, right? Friction doesn't have apply to one surface, right? Right? There will be one object moving across another surface, right? So it is between the surface, the lower surface, and the surface beneath this ball or this object, right? So coefficient of friction mu is always between two surfaces, right? So the coefficient of friction between these two surfaces is equals to 0.4. Now what we can say, it is basically asking what will be the maximum horizontal force that can be applied to the block without causing it to move, right? What is the maximum horizontal force that can be applied to the block without causing it to move? So we need to find out max horizontal force acting, maximum horizontal force acting on the block without acting or can be applied to the block, acting to the block or applied to the block, doesn't matter, without causing it to move or without moving the block, So it is quite obvious, if the block, this block is placed like this on the horizontal surface, it is the normal force acting perpendicularly, and it is we are applying this force F, suppose capital F, on this block, then it will tend to move on this direction only, on the direction of applied force, right? It will tend to move along this direction, and friction will be acting exactly opposite to this direction. Let's just denote this with small f, and small f is acting exactly opposite to the force applied force capital F along the contact of both the surfaces, right? Now the maximum force that can be applied without moving is basically equal to F. This is quite obvious, right? If it surpasses the value of small f, then it is quite obvious that the block will move, because it will be greater than the force acting opposite to this direction, right? So if f is greater than small f, then quite obvious that the block will move, block will start to move, block will move. So when we are applying the force without moving, then it means the maximum value of f, max f, is equal to small f. So small f is equal to basically what? Small f is basically what? Mu times n. This is the formula. Max f, max f applied force is equals to small f equals to mu times n, which is 0.4 into how much did I get? For 50 Newton. Okay, 50 Newton. So, okay, I know I'm writing on a different angle. So, okay, fine. So, basically, F will be mu times n. I hope you can understand. Okay, I was writing on a different angle. But if you're watching on mobile, it will not be that much of trouble. Okay. Okay. So 0.4 in times 50 equals to, that will be also in Newton, right? This is a force, right? So, and 0.4, this coefficient of coefficient of friction, any coefficient, but okay, coefficient of friction is basically unitless, right? This doesn't have any unit. So obviously Newton times our variable, Newton times a constant will be constant only. Yes, Newton only. So 5 times 50 times 0.4 will be 20 Newton. So F equals 20 Newton equals to the F max, F max. So we solved it, right? So this wasn't that much difficult, right? So okay, so this was it. Okay, let's just wrap up, and all the best. If you like it, then please don't forget to click on like. You don't forget to share with your friends or colleagues, whatever you share with your friends, and subscribe. Don't forget to subscribe, and please kindly click on the bell icon. Once you click on the bell icon, you'll get notifications further. You'll be getting notifications of next videos. Okay, so best of luck. Thank you.